Okay, so for each one, we're going to write the equation next to the name of the function. It's actually underneath it once I retyped it. We're going to graph showing the key points, and by key points, I want you to put at least 3. So it's more than just the shape of the graph. You got to have some key points there, and we're going to state the domain and the range of the function. So so at least 3. Parent function of a linear f of x would equal what? X, right? Easy stuff. You've known that for a long time. It is just x. There is another name for the parent function of a linear. You may know what it is. I don't know that y'all know what it is. It starts with an I. Okay. It's called the identity function. Okay, the identity function. So I don't know that you necessarily need a little T-chart, and I didn't give you a whole lot of room for one because I realized that kind of after I did it. I think you have a little bit more room over here to the right than I do. But if so if we just do an XY, I should have made my graphs a little bit smaller. And I put at least 3, but we're actually going to do a few more. Let's do a -2, -1, 0, 1, and 2. Those are good ones to choose unless they don't make sense for a function. Then there's a couple you should kind of know which ones are important points because you should be familiar with the shapes of these graphs. This one, I hope you know, would totally make sense for this. So if x is -2, what's y? -2. It's a really hard question, right? And this is y is f of x. You can look at it that way. -1, 0, 1, and 2, right? So let's plot some points. 0, 0, 1, 1, 2, 2. -1, -1, and 2, -2. And then use a straight edge because you want these to look decent. Your ID should be around your neck, so you can just plop that up on the table and it works beautifully. This is a graph of a what? What's the figure called? A line. So lines have arrows on the end to show that they go on forever, right? So make sure that you actually make it a line and that it's not a restricted domain. Okay. What is the domain of a line? Negative infinity to infinity. Is that true for any line? No. Which lines would not have that as the domain? Huh? Line segments, yes. But which lines? There are lines that wouldn't have that domain either. Vertical lines, right? Vertical lines aren't going to have a domain from negative infinity to infinity, right? All right, so for the parent function, what is the range? Negative infinity to negative infinity, right? Are there any lines that would not have that range? Horizontal lines. Okay, good. All right, so you get the idea, right? That one's a piece of cake. You got that. All right, so absolute value function, I would say you could use those same, I said at least 3. I probably should have said at least 5, but you could use those same x values up there. What does the absolute value function look like? F of x equals what? Absolute value of x. That's why it's called the absolute value function. All right, so turn the page. You're going to come back and fill in the rest of the stuff. Quadratic. This is also called the square function, right? Because f of x equals what? X squared. And I wish I could do this. Move this down because you have room. Oh, this doesn't let me move it down like it used to. All right, well, you have room up at the top. You have more room than I do. You could do your little T-chart up there if you wanted, because I don't think there's really room over to the right or the left. Oh, you have some room over to the left that I don't have. So you could do it over there. So we want x, y. All right. And then we'll do the same ones. -2, -1, 0, 1, and 2. I'll do the easy ones with you. So what is, if x is -2, what's y? 4. If x is -1, what's y? 1, and then the next one is 0, 1, and 4. All right, so we will plot those points. So when x is -2, we're at 4. When x is -1, we're at 1. And you should totally know better and not just connect the dots here, right? Because you know what it is, you know what the shape of it should look like. It's a curve. What do we call this curve? A parabola. So what's my domain? -infinity to infinity. What's my range? 0 to infinity. Do I include the 0? Yes. This is a piece of cake, right? Review? Review, review. All right, so then we have a cubic. For a cubic, f of x equals what? X cubed. And then x and y, I want you to use the same -2, -1, 0, 1, and 2. Then that's all we're going to look at right now. Then let's look at number 5. For number 5, square root function. So what does it look like? Square root of x. So with those same, and I think on the right-hand side, you have more room on the right, so you can put your little chart here. Would the -2, -1, 0 list make sense here? No. Okay, it doesn't really make sense. And so that we get decent points to use, we can use 0, 1, 4, and 9. This, the graph only goes to 8, but you can estimate the 9th one out there. There's a couple things where that might be good for you. Okay, we all good on that? All right. Then we've got the cube root. So that's just cube root of x. Key points here. Can I use negative ones here? Can you take the cube root of a negative? Yes. So that we can get decent points so that we're not, trying to do decimals and stuff here. We can go -8, -1, 0, 1, and 8. And if you want to do more, you can. If you want the in-betweens, but you don't need to. Okay. Any questions on any of those? I'm going to give you the second part so we can just continue on. All right. Because there's 12 of them total that we're going to do. And just want to get you started on them. There's a couple of new ones on this one, but not new where it should be scary to you. Okay, you get all that in just a minute. All right, so this says part 2 up at the top, and it starts with number 7. Make sure I handed you the right things here. Alrighty. So on this one, we have rationals, and I know you did rational functions in algebra 2. Notice that there are 2. There's the rational that is the reciprocal. What page does this go on? 44. And there is the rational that is the inverse square. Well, actually, I say it's new to you. It may not be. It is possible that you did those with Mr. Porter, but I'm not 100% sure. So, but the reciprocal function, or the f of x, the parent function for a rational, what does it look like? 1 over x, okay? Because rational means that you can write it as a ratio of 2 numbers, so it is 1 over x. Okay, that's your rational. And we're going to use, let's see, where do you have room? You have room over here, I guess. So x and y, we're going to do -2, -2, -1, -1/2, 0, 1/2, 1, and 2 on this one. Is this domain going to be -infinity to infinity? What's another way to write negative infinity to infinity, by the way? All real numbers, which is what we could have been doing. Is this one going to be all real numbers? Yes? You sure? Let's see. All right, so negative 2. If I plug in a negative 2, what do I get? Negative 1/2, right? I'll change colors since I'm like crammed over here. Negative 1/2. Negative 1, I get negative 1. Negative 1/2, what does that give me? Negative 2. 0, what does that give me? Undefined, right? That does not exist. You can't have 1 over 0. You can't divide by 0, right? So then the 1/2, when I plug that in, what do I get? 2. When I plug in 1, what do I get? 1. And when I plug in 2, I get 1/2. So we plug in those numbers, or we plot these numbers. So we go to negative 2, we're at negative 1/2. Negative 1, negative 1. And negative 1/2, negative 2. Right. Then I also have 0, which I can't plot. But at 1/2, I'm at 2. At 1, I'm at 1. And at 2, I'm at 1/2. Do you know what this graph looks like before you even do this? Yes. Even though you know what it looks like and you know what the shape is, you still have to have key points plotted there. Okay, so can x ever be 0? No. Is y ever going to be 0? No. So I've got this and this. And that should definitely be a review to you. So what is my domain? Can I start from all the way to the left to the negative infinity? Yes. So it's negative infinity to what? 0. Do I include 0? Nope. That's the whole point of it, right? Then I've got the union, and then I've got 0 to infinity. Because you could do all real numbers for the negative infinity to infinity that we were writing, there is another way to write this. I could write all real numbers, right? Isn't that what all real numbers means? Is that how y'all wrote it, or did you just put all real numbers? That's how you wrote it. Okay, awesome. And then we put this little slash. All real numbers, basically, except for 0. That's another way to say it. Okay. What about the range? Can I go from negative infinity? Yep, up to 0, and then 0 on. So I'll just go ahead and be consistent here. Sometimes consistency is best for you. Like if you always want to do them in intervals so that you can think of it that way. But you do kind of have to understand both if it's some sort of multiple choice thing on on an AP exam, or if it is written in the question, those sorts of things, so that you can at least read it even if you're not going to write it that way. Okay. Everybody good with that? All right. Anybody are you familiar with the inverse square? Like, is that something that you haven't even heard? I meant to ask Ms. McWhorter that, but I forgot. Okay. Now, it's my understanding that it's new to you. All right. Well, it's what it sounds like. What's the square function? X squared. It's the quadratic, right? So the inverse is just 1 over that. So this is just 1 over x squared. But it's still a rational. That's why it's still in the rational category there. And so I want you to use the same domain points that you had on the other ones. Actually, yeah. Use the same ones. Okay. So the negative 2, we'll write it down. X, Y. I want you to use negative 2, then negative 1, then negative 1/2, 0, 1/2, 1, and 2. And even though that one's new, I want you to explore that one on your own. All right, so let's go to exponential. So we can get you started on that one. Don't get right in that one though. Okay, so for exponential, and I'm kind of mad at myself. I think I updated this, and I used to be able to move this down so I had more space, and I can't do that anymore. But you have more space up at the top than I do, so we're going to use some of that space. And for the exponential, you're actually going to have two graphs, okay? You're going to do one where, well, actually, what does f of x look like first? Tell me what I write here. B to the x, right? Because it's some number to the x, and so we use b for that. So it's b to the x. Okay, that's what it looks like. So we're going to do two different graphs. So I want you to grab, there's colored pencils in the supply box. And you need two different colors that are like distinct different colors. All right, so we're going to do one where we're going to do, and you can use your pencil. I'll tell you when to use the colored pencil so you don't have to write with it. We're going to do one where b is greater than 1. And for when b is greater than 1, we're going to use f of x is equal to 2 to the x. So then use your colored pencil, say I would use purple, to make your, like the t part of the t table, so you don't have to actually write numbers in it. So because you're going to do two graphs on this one grid. So when you actually graph this one, like I used purple here for my little t chart, that means I'm going to graph it in purple when I get there. And then you can write in your pencil, you don't have to write the numbers and stuff. For x and y, we're going to use -2, -1, 0, 1, and 2. Okay? And then, I'm still using my pencil here. We're going to do one where, oops, that is not my pencil. Green is my pencil. We're going to do one where b is between 0 and 1. And for that one, we're going to do f of x is equal to 1/2 to the x. Then you grab your other colored pencil and make a t-chart with a different color. And use the same numbers. So x, y, and, sorry, I can't move my thing down, so these are tiny. -2, -1, 0, 1, and 2. That way you have two different ones, but they're different colors so you can tell what they are and you know which one goes with which graph. And if you want to also, say, okay, maybe underline this with your colored pencils so that you know which ones it goes with, whatever. But I wanted you to be able to match them up but not have to write in the colored pencil a lot. And these are erasable, so I got erasable ones on purpose because none of us are perfect. We good? Do you understand what I want you to do there? I'll take that as a yes. Y'all are so expressive. Okay. Now let's go down and look at the logarithmic. Parent function for a log is f of x equals what? Log base what in general? Base b. So log base b of x. You need two graphs on this one also. Okay, and so we have a little bit more room down at the bottom on this. Like you have extra room at the bottom, extra room at the top. So we'll do these down at the bottom. So again, you have your two colors, right? So we're going to do one where f of x, I'm sorry, not f of x, where b, all right, forget that, where b is greater than 1. So for that one, f of x is equal to log base 2 of x. And then same idea, we're going to do them in different colors. So here's one, x, y. Now, when you're graphing a log function, do you want to go through and choose a bunch of x's? Do you know what the log base 2 of 5 is like that without a calculator? No. Can you rewrite a log to where it makes more sense to you without a calculator? Yes. Okay, what does f of x represent? Y. Okay, so to rewrite this in exponential form, this is actually 2 to the what power? 2 to the y power equals x, right? So 2 to the y power equals x. So when you're graphing these, you don't want to go through and choose your x's. You want to go through and choose your y's, right? Remember that? Okay. So we're going to choose on there the same ones that we did on the other. So the negative 2 to 2. But we're choosing y's this time. So in the y column, it's negative 2, negative 1, 0, 1, and 2. So in this case, you plug in your y and you get your x. Then we also want where b is fraction. So we're going to do f of x equals log base 1/2 of x. So my chart here, x, y. To rewrite this, this would be 1/2 to the what? Y power equals x. So again, we're choosing y's. So negative 2, negative 1, 0, 1, and 2. Everybody okay with that? Right? Make it easier on yourself, not harder. And then, again, if you want to kind of, so this graph should be in whatever color you used here. This graph should be in whatever color you used here, so you can easily tell the difference between the two. Okay? We good? Let's go back up here. I do want to write out right here, though, that to redo this, since this is y, just in general, a log function like this, it's b to the y power equals x, just so you have it there kind of generically, too, in case you don't remember that. Everybody good? Okay. So the next one is a semicircle. So why do you think it's a semicircle and not a circle? Why don't I have a parent function for a circle? It's what? It's not a function, right? Okay, so true story, because, you know, we all have those moments. I don't know if y'all recall, and sometimes every year I don't do it, but in geometry when we did, we talked about conic sections very briefly. I brought out the cone, I showed y'all things, we even looked at the graphs on the calculator. We didn't do much more than just kind of look at them. And so I was talking about parent functions, and so I went and I thought, okay, I'm just like planning out my thoughts, and this was last year, because I didn't really connect it with parent functions before that, but I was like, okay, so I always have trouble with y equals x. What the heck is that? We talk about that, that's a parent function. So then we'll talk about the parent function of a quadratic and that kind of stuff. So as I going through that, and I'm like, okay, so the generic forms of the circles and the hyperbola, and I was like, what the heck is that? So like I'm spending, I don't know, I spent probably 30 minutes like Googling, because I thought, why can't I think of what that parent function is and what it looks like? I know this stuff. So I'm Googling. I can't find it anywhere. Like, why can't I find the parent function of a circle and an ellipse? I mean, I was like, this is driving me crazy. And I was about to call Mr. Ackerman when all of a sudden I was like, oh, I can't find the parent function because it's not a function, right? And so I was like, duh. I mean, I'm saying it to myself in my head. Clearly I know this stuff, but it was just that time of it. No wonder. I'm like, how is this not on the internet? Well, then I'm wondering, how did somebody on the internet not say, hey, stupid, stop Googling this because it's not a function? Anyway, so that's I'll admit to you when I do just really dumb things. So you can't have, you have to use the A's and the B's here. You can have it for a semicircle, but you can't have just all generic numbers, just like you couldn't for a log, right? Because there's lots of different forms. So for a semicircle, it has to be a semicircle, not a circle, because you can only do half at a time. But it is square root of what? Y'all did these last year, right? What is my generic that I write in here? It is a squared minus x squared. Which kind of bothers me because the reason it's like that is because you have a circle that is x squared plus y squared equals r squared. So this is a and not r, but it kind of means something different. But basically that is the radius of the circle. And if you know that, then you don't necessarily even need a bunch of t-charts and stuff. But we are going to, so that we can do an example, we need some actual numbers. So what we're going to use for our example is f of x equals the square root of 9 minus x squared. So since this comes from, all right, the equation of a circle, remember it's x, well, let's talk about it. X squared plus y squared equals r squared. That's where this is coming from, okay? That's not a function, that's why I want to get half of it. So this right here, when I solve for y, I subtract the x squared over, and then I take the square root. So this is the radius. So a equals the radius. Right? Because the actual standard form of a circle is x minus h squared, y minus k squared equals r squared. The h and the k are the center point. Well, the center is at 0, 0. Okay? So when you do this little chart that you can use, just 3 of them, we're going to use -3, 0, and 3. So to think generically about what the domain is. Well, actually, let's go ahead and do this one and we'll graph it. So if x is -3, what is y? 0, because -3 squared is 9, and 9 minus 9 is 0. So it's 0. I plug in 0, what do I get? 3. And I plug in 3, I get 0. Right? Which should make sense, because it's a semicircle. Centered at 0, the radius is 3. So I go to -3, 0, 0, 3, and 3, 0. And then you just do your best to make it look circular. It doesn't have to be dotted, but I usually at least start mine out like that. I have a better chance of getting it curved right. Still not right. So this specific domain, for this one that we just drew, what's the domain? -3 to 3, right? Okay, but I want the domain for any of the semicircles. So instead of putting -3 to 3, what would I write? -a. Because it isn't a 3, right? Look at that. A equals 3 right here. This is a squared. So a equals 3 in this specific case. And 3 is the radius, right? So a is the radius. That's 3. So that's what I do here. So I go from -a. Do I include it? Yes. And then on the other side, it has to go to a, because a is the radius. Does that make sense to you? You see how to make it generic once you figure out what it is? The range. Where do I start? 0. So for this one specifically, obviously, is it ever going to be anything less than 0, whatever I choose for a? Is that possible? No, because I'm taking the square root, right? So it's going to start at 0. Do I include it? Yes. And then what's the top point of my range? A, right? Because it's a circle. And I include it. Okay, everybody okay with that? All right. So let's look at the greatest integer. That one's new to you also. Right? So your greatest integer function. It looks like this. Right? Is x, and then it has brackets, but the bracket like has an extra line in it like that. Greatest integer function. If you were trying to calculate how many people could fit on the bus, and you had some equation, you figured it out, and your answer is 35.2. How many people can you put on the bus? 35, right? Because you're not going to put part of a person, yes? So that's how I want you to think about this greatest integer, is how many people fit on a bus. What if I got 35? Well, then the answer is 35. But if I got 35.2, then it is 35. What if I got 34.9? then it's 34, right? I'm not rounding because if I can't fit that whole person on there, right? 34.2, 34.3, 34.4, all of those would be 34 because the words that I want you to write down with this is that a greatest integer function is the greatest integer less than or equal to x, or whatever it is that you're putting in there, okay? Less than or equal to. It's the integer to the left. Okay, so it's the greatest integer less than or equal to x. Everybody okay with that? All right, so let's go back up here. Another name for the greatest integer function is a step function. So let's make a little chart that we can do over here. So let's start with -2, -1.5, -1, 0, 1, 2, 2.5, 2.7, and 3. Okay. So, when I plug in -2, what's the greatest integer less than or equal to -2? -2, right? When I plug in 1.5, what's the greatest integer less than or equal to -1.5? Think about that one. Is it -1 or negative? The less than is -1 less than 1.5? Think about that. -2 is less than 1.5, right? When it's negative, it's opposite. So it's the one to the left, because left is less, right? So this is also -2. -1 is -1. 0 is 0. 1 is 1. 2 is 2. 2.5 is what? 2. 2.7 is 2. 3 is 3. Okay, so let's plot these and see what happens. So I'm going to go to -2, -2, right? I'm going to go to -1.5. I'm still at -2. At -1, I'm at -1. At 0, I'm at 0. 1, I'm at 1. At 2, I'm at 2. If I'm just picking those numbers, it kind of looks like it should be a line, right? If I'm at 2.5, I'm at 2. If I'm at 2.7, I'm at 2. But if I'm at 3, I'm at 3. This kind of looks like a hot mess right now, right? Let's think about this. If I was at 1.5, what's my answer? 1. If I'm at 1.9, where am I? 1. If I'm at 1.9 repeating forever, where am I? 1. But when I'm at 2, I'm where? At 2. So I can't actually get to 2, but you see how it goes all along right there? This is why it's called a step function. So when I'm at 2, I'm at 2. 2.5, I'm at 2. 2.7, I'm at 2. 2.9 repeating, I'm at 2. But at 3, I'm at 3 because I can't actually get there. And it looks like that. So this is what your step function looks like. You see the open circle all the way to the close like this? Think about what's happening, because any of those decimals that you pick, it's the greatest integer to the left. Okay? You see how that works? You see how to reason through it? So if I'm at 1, 2, 3, what was it? 1, 2, 3.5, I'm at 3. 3.6, 3.7, but 3.9 repeating, I'm still at 3. But at 4, I jump to 4. 4.1, 2, 3, 4, all is 4. But at 5, I jump to 5. All those are 5, but at 6, I jump to 6. and so forth. You see how that works? And that's what that means by greater than, or I'm sorry, by less than or equal to. So it is the integer to the left. What is your domain here? Can I snap all that together? Yeah, I sure can. So my domain, just for me to stay consistent, is negative infinity to infinity, which is all real numbers. What's your range? Turn that off, please. Is it all real numbers? Is 1.5 a real number? It is, right? Can y be 1.5? No. All of my y values are what? Whole numbers. But whole numbers that are positive and negative are called what? Starts with an I. Integers. So your range, because I can't write them out because there's an infinite amount of them, right? Our range is the integers. Okay. We okay with that? I know that one's brand new to you. We'll come back and talk about it again. But again, think about it as people on a bus. Okay? People in a classroom. I can't put half a kid in here, right? Sometimes I'd like for you to leave your mouth outside, but I have to put all of you in here. And so it has to be the whole number, but it has to be less than. It's not a rounding up thing because we're talking about people or things. Okay? We good? Any questions? You can finish the rest of these. I did the new ones with you and some of the easy ones. Finish this for tomorrow because you're going to need it for what we're doing tomorrow. Okay? Whether or not it's glued in by tomorrow, it doesn't matter. If it's easier for you to write on it before you glue it in, I'm fine with that. You got a couple of minutes left, so we don't have enough time to go over the quiz. We can do that tomorrow. But anybody have any questions for me? We're all good? Yes? Okay, yes, ma'am.